damping, we learned that damping is the decrease in amplitude of an oscillating system, and the oscillations undergoes damping is called the damped oscillations, and you can see that the amplitude decreases over time, and oscillating systems undergo damping is because what? Because it loses energy to the surrounding as heat energy. So when there's a frictions or what, it loses energy to the surroundings, then it undergoes damping. But for the damped oscillations, the frequency of the systems remain unchanged. Okay, the frequency is still the same, only the amplitude decreases over time. And then we learned that there are two types of damping. Okay, but as I told you, this is not important actually. So you just need to know that there are two types: internal damping and external damping. Internal damping is caused by the extensions and compressions of the molecule, and external damping is caused by the frictional force. But the graph of damping is important, okay? Yeah, because in exam usually they will ask you to sketch the graph of damping, and usually there are two types of graph. Displacement time graph, it will look something like this, or sometimes they may ask you to plot the amplitude time graph, and the amplitude time graph look like this. Okay, just shows the amplitude decreases over time, okay, and there's no negative values. So this is displacement time graph, and this is amplitude time graph, and don't get this wrong, okay? Yeah, because a lot of students, especially when they ask about amplitude time graph, a lot of students, they will still give you to give this answer, the displacement time graph. So make sure that you don't make this mistake. And then we also learn force oscillations. Okay, what is force oscillations? So in a damped oscillations, external force must apply to the system to enable the oscillations to go on continuously. Yeah, for example, let's say we have an oscillating pendulums, and it loses energy, the mechanical energy loses to the surrounding, and this cause the amplitude decreases over time. The amplitude decreases over time. But if you don't want it to stop, because you see finally it will stop, okay? Finally it will stop. But if you don't want it to stop, then you must give a force. External force must be given to the system to help it to oscillate continuously. And if external force is given, then that is called a force oscillations. If there's no external force, then it's just a natural oscillations. But if a force is given, then it's called a force oscillations. Okay, so that is force oscillations. So oscillations with the help of external force or forces is called a force oscillations, and by definitions, a force oscillation is the oscillations with the help of external force or forces. We are going to continue with resonance. Now, to understand resonance, the first thing that you need to understand is the natural frequency. The natural frequency of an oscillating system is the frequency of the systems when there is no external force or forces acting on it. So if you do not give any force, that frequency of the oscillating system is called the natural frequency. Usually they will ask you about the definitions. You just need to know that there's such thing called natural frequency, and that's the frequency if you do not disturb, okay, an oscillating system, the frequency will be the natural frequency.